Thank you. Yes, I'm Dan Hill from Amazon's Personalization Sciences team, and I'm here to talk to you about window shopping. So I'm sure that we've all had an experience where maybe we've gone to the mall, and we come back with far more purchases than we had intended to at the beginning of the day. And when you think about that, you realize that purchase behavior has a lot of serendipity and inspiration that factors into it. So I went to the mall to buy this DVD I wanted. Oh, and I saw a cool pair of shoes. I went home with that too. Now, in e-commerce, we don't necessarily sort of satisfy this need. We're sort of more aimed at query-based search. I want this specific camera model, show it to me, I'll buy it. So at Amazon, we wanted to be able to satisfy this different mode of search. And so we developed this new area of the website called the stream. So this is Amazon Stream. You can go to this amazon.com/stream and check it out for yourself. It's a relatively new area that we started last year. And what it is an infinite scroll of beautiful or interesting items. So the idea is that a customer can, at their leisure, come to the website, browse a few items, see if something inspires them, all in the absence of any specific search query. So specifically on the machine learning team, what we wanted to satisfy here, what we needed to do was solve the problem of, in the absence of the context of a query, what do we show the customer? How do we rearrange the products in order to serve them? So obviously the solution isn't going to be just put the highest click-through rate items at the top. We have to sort of address all these other concerns related to this more visual browsing experience. So one of those is freshness. So we have a catalog that has a high level of churn. We want to surface new products without degrading the quality of the stream. Well, we've heard about this a few times today already about diversity. Here, it's sort of a specific product requirement that we want to create a visually interesting stream. So we want to have a variety of products for customers to look at. But there's also the more traditional reason of hedging against uncertainty and what the customer's intent is on coming to the stream that day. Next is seasonality. We need to adapt quickly to trends in fashion. And of course, personalization, which is that we want to surface products that are more relevant to the specific customer's interests. So because of lack of time, I'm going to have to go over this at sort of a high level. Please refer to the paper for questions, but I'm going to show you the components that we put together in order to lay out the stream. So the first component is just simple product ranking. So we use a Bayesian linear probate regression to map product features onto customer click-through rates. The advantage of using a Bayesian model is that we end up not learning just weights, but also uncertainty about those weights, and then we can use an explore-exploit algorithm, such as Thompson sampling, in order to score the products. And so Thompson sampling will tend to give high scores to products that are liked by customers in terms of their click-through rate, but also ones that we have a high uncertainty about because those products are new to our catalog. Of course, if you just rank things just by click-through rate, what you end up getting is a very stale experience. So products that have similar attributes are going to have similar scores, and so you're going to get sort of clustering within your ranked list of very similar products. Okay, so how do we introduce diversity? So for us, diversity means that these streams should have products from a wide variety of categories, where we define categories as the concatenation of the department that the product came from, whether it's women's, men's, or home, the product type, in this case it's a dress, and the price range. And then using these categories, we apply this already mentioned concept of submodular utility, which just represents the diminishing returns of showing the same category repeatedly to the customer. So here is the utility function that we optimize for. So it's basically, if you have a set of products D, the utility of that is a sum over all of the different categories, where the first term is a category weight, which I'll discuss in a second, times a submodular term, so basically just a logarithm applied to how often have we seen this category already, and the original score for those products. Now, in order to sort of make sure that more popular categories are more represented than less popular categories, regardless of product score, we separately learn a set of category weights W based off of customers' click-through rate, and additionally using a rolling window so that what we show to the customer is based off of just the most recent period of time. And on top of that, we also want to personalize for customers who we already have some information about, so who have a history with us. So in order to do that, we further modify the category weights, so essentially just learning a personalized weight based off of the customer's own clicks using the sort of the global category weights as a prior. However, we found when we do this, you often get customers into the filter bubble. So this is a histogram of a customer, what categories a customer had clicked on. You can see it's very sparse. So we use diffusion by a category correlation matrix. Basically means customers who like this category also tend to like this category in order to spread out their interests into a more dense customer preferences vector. Don't have time to go through our experiments that we performed in too much detail. Please look at the paper. So essentially just what we have here is the different components of our system have all been A/B tested, and we can see significant lift for both the choice of using submodular diversity, optimizing the adaptive category weights, and incorporating personalization. That's about it. This is the team that I work with in personalization sciences, and I'm happy to take any questions you have. Thanks.
We've got one question right in the front row.
Thanks. I think it's really exciting things. We've been missing this kind of a paper on the workshop on interfaces. Question is, I kind of missing the point. Are you learning kind of collaborative filtering, learning from the community about the diversity of categories? You're just learning from the user alone. To what extent are you using the wisdom of the community? Because it might be very weird category level collaborative filtering, which could help. Are you using it?
I'd say the general strategy is that we use global activity as a prior, and then on top of that, in sort of a regularized way, add in what we learned from the individual customer. So if we don't have any information on you, you basically will get the global experience, and then the more and more you use it, the more those weights gravitate towards your own behavior.
Back here.
Hi, Dan Cosley, Cornell and NSF. I was wondering, the streams idea is really cool. What do you think would happen if you had multiple different streams, a little more like one of the Netflix-style interfaces that tries to group by some sort of semantic relatedness?
Oh, finally found you. Yeah, so that is part of the experience now. If you go, there's actually multiple tabs, so with very different product categories like fashion versus sort of giftable items. I think there is an opportunity there to sort of like learn the differences between how people shop in one mode versus the other, but we're not quite sort of combining models yet.
We have one here on the front right from Stage View.
I'm really curious because just a few presenters before you, someone explained that Thompson sampling was too easy, and it seems you're able to manage it. You're even able to do it each time I scroll down my page on time. So is it a problem for you to do Thompson sampling, or how do you manage it?
So the question was just whether about the computational complexity of performing the Thompson sampling?
Yeah, what we think, often thinking about UCB like a system and Thompson sampling, it cannot scale to the 1 millisecond answer or things like that when you scroll down your page, while in what you present, it looks like it's working.
So I think there may be a point about like whether someone is Thompson sampling by resampling all parameters once per product versus once per page. It's actually very quick for our model just to sample one time per page, and then those weights are persisted for the entire layout of the stream. So that is definitely not our computational bottleneck right now. The bottleneck is usually because the way you have to sort of recalculate scores due to submodularity. Every time you place a product, the scores for all the other products have now changed. And so how do you intelligently rescore just the ones that need to be rescored?
So we don't have time for me to ask whether if I like a product, I can have a drone deliver it to me, so I won't, but we will thank you for the presentation.